I'm going to be going over the Unit 10 note packet, and we're looking at day 2. And we're still doing limits, except for today we are not looking at graphs. Today we're going to figure out how to find the limit algebraically. And up top I just have a review, and just as a reminder, when the denominator and the numerator of a rational function, remind yourself what a rational function is. A rational function is a fraction, contain a common factor, a whole appears in the graph. So I have an example here, and the example is y equals x squared minus 9 over x plus 3. Well, hopefully we remember how to factor the numerator. The numerator is the difference of two perfect squares. So the numerator factors into x minus 3 times x plus 3. The denominator stays the same. I see a common factor. That means the same thing on the top and the bottom. When that happens, that creates a hole in our graph. Now the hole happens at the x value that would make that 0. So to find the hole, you could do this in your head, but whatever that common factor is, set it equal to 0, and the hole's happening at -3. So that's where that x value comes from. But then you might say, okay, what's the y value of the hole? Well, to find the y value of the hole, you go back into your fraction here, and you plug in for x, you're going to plug in -3 here, in for this x, -3 minus 3. Don't plug in anything to what you crossed off, just what's left, and y equals -6. And that's where that piece comes from. So I have two examples for us to try, and the directions are find the holes in the following graph. So please work along with me. So the first thing I want to do to find a hole is I want to factor the numerator and the denominator. So this numerator is going to factor. I need to think of two numbers that multiply to -10 and add up to +3. So x and x. And my numbers are going to be +5 and -2. That's what this factors into. The denominator is still x minus 2. Okay, so now I'm going to look and say, okay, do I have a common factor? And I do. My common factor is right here, the x minus 2. So those are going to cross off, and whenever we have a common factor, it's going to make a hole. So I'm going to figure out where the hole is. So the x coordinate of the hole is going to be +2. And to find the y coordinate of the hole, I'm going to go into what's left, which is just x plus 5, and I'm going to plug in 2 for x. My y coordinate is going to be 7. So the hole in my graph is going to happen at 2, 7. And I'm going to show you what this would look like in my calculator. So I'm going to put my calculator under here. And into y1, you can ignore what I have in y2, but into y1, I have the original problem here for number 1. And if I hit graph, my graph looks like this. And on my calculator, you can't see a hole. But if I were to hit the trace button on my calculator, okay, if I hit trace right here, and then it gives me x and y on the bottom, if I just type in my x value of 2, so I'm just typing in the number 2, and I'm going to press enter, and it's not going to give me a y value. It says y equals, and it's blank. And what that means is there's a hole when x is 2. I figured out that the hole's happening at 2, 7, but the calculator doesn't give me the value because there's a hole there. If I were to just use my cursor and move to the left or to the right a little bit, my y value will jump back on, and it should be around the number 7. So I'm going to move to the left, and sure enough, I get 6.7. And if I scoot to the right, 6.9. I'm right about 7. But at 2 exactly, there's a hole. So there's no y value for that. Okay, let's try number 2. Number 2 is all nice and factored for us. And what I notice is a common factor right here. The x minus 4 is common factor. So that's going to make a hole. And the hole is going to happen at x is +4. To find the y coordinate of the hole, I'm going to go into the function that I'm given. And what's left, I'm going to put 4 in for x. So 4 minus 2 over 4 times 4 minus 3 squared. Simplify. and I get 2/4 or 1/2. So this time the whole is happening at 1/2. I'm going to put my calculator under the screen again. We'll take a look. This time I have that original function typed into my y equals in the calculator, and I'm going to hit graph. Okay, on my graph, oh, it's kind of a strange graph. I see some asymptotes there, but what I'm going to focus on is when I press the trace button, and if I type in the number 4, x equals 4, when I press enter, my y should be blank, and it is, because there's a hole at 4, 1/2. Okay, if I move to the left a little bit, I'm at 0.6, 0.4. I'm right about 0.5. But again, if I were to type in x equals 4, there's no y value. So that's how we find a hole. Now, we're going to move down to limits. So we said last week we evaluated limits by looking at a graph. This week, we'll learn how to evaluate them without having to graph them. So if we look down, problem number 3, and remember the way that we say this out loud is the limit as x approaches 3 of x squared plus 1. So the first thing I always try to do is just substitute in. So what I mean by substitute in is I say equals, and I'm just going to take 3 and plug it in for x. So 3 squared plus 1, 9 plus 1, and I get 10. Okay, if I get an answer, that's my answer. Okay, that's the easiest way to do a limit problem, to substitute in. Okay, let's try number 4. So same idea here, it's the limit as x approaches 2 of 3x plus 1. So I'm going to go in, and where I see x, I'm going to substitute in 2. 6 plus 1 equals 7. Try to keep your work nice and neat. When you make it to calculus, your work is where you're going to get credit. Your final answer is usually worth very little. It's all your work along the way. So get in the habit of showing nice, neat work. Okay, number 5. Same deal. Find the limit as x approaches -1 of 4x squared plus 3. So I'm going to do 4. Make sure you put that -1 in parentheses when you sub it in. And the importance of that is that make sure you're squaring -1. -1 quantity squared is just 1. And so 4 plus 3, and you don't have to show all this work, but 4 plus 3 is 7. So my answer is 7. I want to show you what this would look like in the calculator. So if I went into my calculator and put in this function, 4x squared plus 3, and hit graph, I'm going to see a parabola. And if I'm trying to find the limit as x approaches -1, if I hit trace and typed in -1, I better get this y value of 7 because there's not a hole in this graph. And sure enough, when x is -1, the y value is 7. And remember, the limit is just what is the y value getting really, really close to. Okay, let's try number 6. Always substitute first. That's what our directions say. So let's imagine that we're going to substitute 3 in. 3 minus 3 over 3 squared minus 9. I'm noticing up in the numerator I'm getting a 0. The denominator I'm also getting a 0. 9 minus 9 is 0. So we have a problem because in math we can never divide by 0. So when this happens, don't just say, oh, doesn't work, doesn't exist. That's not the case. We have to try another method. So if you ever end up with the 0 on the denominator, you want to try another method. So if you flip your paper over, we're going to talk about the second method that we can try here. Okay, on the back, we have when substituting does not work, we have to resort to other methods. So the first thing I typically think about is factoring. Now let's look at problem number 7. You might notice this is the same problem that was just on the front. It was the same as number 6. And we had determined that this was 0 over 0. So we have to try something else. And I'm going to take this problem and I'm going to factor it. I notice the denominator can factor. please, please be careful with your notation. I have to recopy the word limit as x approaches 3. If I am ever simplifying this thing, factoring, doing anything else, I need to recopy the word limit. The top is x minus 3. The bottom is x minus 3 times x plus 3. Okay? And now I notice that there's a common factor, which hopefully we remember that makes a whole, but those are going to cross off. I'm not asking for the whole. We're asking for the limit. If they cross off, I'll assume that there's a 1 left up top because there's nothing else up there. And now I'm ready to plug in. Now I've eliminated that part of the bottom that was the problem, and I'm ready to plug in. If I plug in, I don't need to write the word limit anymore. Numerator's 1. The denominator is 3 plus 3, and my answer is 1/6. So just to be clear, you have to keep writing the word limit until it's time to plug in. Basically, if you ever have x's still in there, you better have the word limit in front. As soon as you substitute in, you no longer need the word limit. Okay, let's look at problem number 8. Problem number 8, this says x approaches -5. It's a really small -5, but I'm realizing that if I plug in -5 mentally into the numerator, 25 minus 25 is 0. And if I plug it into the denominator, -5 plus 5 is 0. So I have a problem, so I need to factor. So again, I'm going to recopy the word limit. My numerator factors into x plus 5 times x minus 5. My denominator stays at x plus 5. Now I notice there's a common factor. I can slash them out. It is going to make a whole. In fact, we'll look at the graph of this one in just a second. It makes a whole, but those are gone. And now I'm ready to plug in. Now I no longer need to write the word limit. I'm just going to take -5 and plug it in for x. -5 minus 5, and my answer is -10. We're going to take a look at this one on our calculator. Okay, so I have the function typed into my calculator here. And if I go to hit graph, I'm going to try to figure out what's happening at -5. Now, hopefully we realize that there was a hole here at -5 because remember there was a common factor. If I hit the trace key and I type in -5 for x, when I hit enter, there should be no y value because there's a hole. And sure enough, the y value is empty. But remember from last week, a limit can still exist even at a hole. There's a little hole down here on my calculator. I can't see it, but it's down here. And a limit exists even if there's a hole, as long as it's coming from the right and coming from the left, coming in on the same y value. Okay, let's look at problem number 9. Problem number 9, I would try to sub in first. I would attempt to do this. 2 squared is 4. 5 times 2 is 10, plus 6. My numerator, I end up with 0. My denominator, if I plug 2 in, I have 4 minus 2 minus 2. I also get 0. So I tried subbing in. Did not work. So now I'm going to find the limit as x approaches 2, and I'm going to factor. Okay. So remember this type of factoring. My numerator is a trinomial, 3 terms, and it's a quadratic, meaning an x squared. I'm going to factor it. I'm going to try to think of 2 numbers that multiply to 6 and add up to -5. And those are going to be -3 and -2. I'm going to do the same thing on the denominator. Set up 2 separate factors, x and x. And I need to think of numbers that multiply to -2 and add up to -1. And those are going to be +1 and -2. And it doesn't matter which order you write them in, but it needs to be a +1 and a -2. And then common factor, slash them out. There's going to be a hole in this graph, but we're not looking for the hole. What we're looking for is the limit. So now we're ready to plug in. I no longer need to write the word limit. If I put 2 in, 2 minus 3, 2 plus 1. And 2 minus 3 is negative 1. The denominator is 3. My answer is going to be negative 1/3. And as you're practicing, please use good notation. Please write that limit. Just get in the habit of it. All right, number 10. If I try to plug 1 in, the top 1 minus 1 I can tell is 0. The denominator is 1 minus 1 plus 1 minus 1. Denominator is also 0. So I need to try something else. We're going to try to factor. So we're going to rewrite the word limit. The numerator does not factor. That's just x minus 1. The denominator, let's try to remember how to factor if we have 4 terms. If I have 4 terms, I typically like to try grouping. We group the first 2 together and say, what can factor out of those first 2? Well, x squared can factor out of those first 2, and I'm left with x minus 1. Then I move to these next 2, and I say, what can factor out of those so that I'm left with x minus 1? Well, nothing really factors out, so I'm just going to say 1. Make sure you do put that plus 1 there, or at least the plus, x minus 1. And then the way that grouping works, I'm going to rewrite lim as x approaches 1. Numerator stays the same. And the way that grouping works is on the denominator, if I have the same factor, I can factor that out. I write the parentheses once, x minus 1, and then I write what's in front of the parentheses as my next factor, x squared plus 1. And now I see a common factor, top and bottom. I'm going to slash those out. There's nothing left up top, so I'm going to put a 1 there. And now I'm ready to substitute in. So I no longer need to write the word limit. If I substitute in, the numerator is just the number 1. The denominator is 1 squared plus 1. And my final answer is going to be 1/2. The last method that we're going to go through is called the rationalizing technique. And if I look at number 11, the first thing I still want to try to do is sub in. But if I substitute 0 in, I immediately see a problem because I have a 0 in the bottom. So that's not going to work. This thing does not look factorable. Typically, if you see radicals in your problem, you want to do something called rationalize. And what you want to do is you want to take your problem and you want to multiply by a fraction. To determine what the fraction is, it's going to be the conjugate of this numerator in this case because it has the square root. The conjugate is the square root of x plus 1 plus 1. The only thing that's changing when you do a conjugate is this term, this symbol in between your terms. Now, I can't just randomly multiply the problem by this square root of x plus 1 plus 1. So I multiply the top and the bottom by the exact same thing. And then it's just like multiplying by 1, so it doesn't change the problem. All right, now I need to simplify that. So now I'm going to say lim as x approaches 0. Now that might look pretty difficult to simplify. On the numerator, I'm going to put a big parenthesis around this and around this, and I'm going to have to multiply that out. When I multiply it out, I'm going to FOIL it out, but something nice is going to happen when I FOIL this. Let's try. The first term of the FOIL is the square root of x plus 1 times the square root of x plus 1, which is just x plus 1. If I try to do the outer term of the FOIL, I get the square root of x plus 1 times 1. And if I do the inner terms of the FOIL, I get the square root of x plus 1 times negative 1. And so what happens is the outer and the inner terms of the FOIL are always going to cross off when you multiply conjugates. So I don't even need to do those. I can jump right to the last. The last means multiply the last term here with the last term here. Negative 1 times 1 is negative 1. On the denominator, don't distribute, just recopy. So I'm going to recopy the x, and then I'm going to recopy all this stuff in parentheses because it's x times all of this. And after I do that, then I'm going to start to simplify and see what can cancel out. So 1 minus 1, gone. I also notice now I have a common factor on the top and the bottom. So now I'm going to slash those out. And because there's nothing left in the numerator, What do we put in the numerator when there's nothing left? A 1. And now I'm ready to substitute in. So now I'm going to write the equal sign. I do not need to write the word limit because I'm substituting in. 1 over. I'm going to put 0 in for x. And if I simplify, I have 1 over 1 plus 1, or 1/2 being my final answer. I want to show you what this one would look like in the calculator. Okay, I've got this original problem typed into my calculator, and if I hit graph, my graph looks like this. If I tried to see when x is 0, what is y, I'm not going to get anything. I'm going to type in x is 0, and notice that the y is blank, and that's because there was a hole at 0. So I can't see it this way. I could use my trace and just scoot to the right and the left a little bit, and notice that that y value is pretty darn close to 0.5. Which was my answer. I want to show you something else on the calculator. If you hit on your calculator, second window, what it does is it sets up your table. And it doesn't matter what your table start is at right now. I would recommend, though, changing your table start to whatever x is approaching. So in this problem, x is approaching 0. So I would make my table start at 0. Your change in table is probably not at this very small number. Your change in table might be 1 right now. Now, if I go to my table after this, I'm going to hit second graph to go to my table. And I look at my table, and what I'm trying to focus on is as x approaches 0, I notice that there's an error over here, but I want to see coming from the left, coming from the right, what the y values are getting close to. And I can't tell. It's definitely going to be between 1 and 0.4, but I'm not really sure. So what you can do is go back to second window. Go back to your table set. Let's make the table start at 0 again. And then this triangle table, that means delta table or the change in the table, make it really small, like 0.001. And now go to your table, second graph. And now what's happening is it really zooms in or focuses on x is 0. Coming in from the left, getting really, really close from the left, getting really, really close from the right, look at those y values, and I can see that the y values from both sides are coming in on 0.5, which is the same thing as 1/2. So even though there's an error, the y values are coming in on 0.5, so I can confirm that that is my answer. Okay, one last one, number 12, and I have a typo on number 12. I have a mixture of x's and z's in my problem. I prefer x's, so I'm going to change these guys over to x, but just make sure that they're all the same variable. Okay, if I tried to substitute 0 in, I get the square root of 6 minus the square root of 6, 0, and I get 0 in the bottom. It doesn't work. So I'm going to try to multiply by the conjugate. So square root of 6 minus x plus, remember that's the only thing that changes, the square root of 6. Same exact thing on the denominator always. And then I'm going to simplify. So make sure that you recopy the word limit as x approaches 0. Put this up in parentheses, and we're going to FOIL. So on my numerator, the square root of 6 minus x times the square root of 6 minus x, just 6 minus x. Just like before, the outer and the inner term of the FOIL cancel out, so that's great. You don't even need to worry about those. The last term of the FOIL is negative square root of 6 times positive square root of 6, which is negative 6. Denominator stays the same, x times, in parentheses, square root of 6 minus x plus the square root of 6. Cancel out things that can cancel. 6 minus 6 can go away. Negative x over x, almost exactly the same. I can slash out those x's, but when I do that, make sure that you're left with the negative 1 on the numerator. Okay, we've got a negative 1 up there. Now we're ready to substitute in. I don't need to write the word limit anymore. Numerator, I have negative 1. Denominator, I have the square root of 6 minus 0, because I'm subbing 0 in, plus the square root of 6. Negative 1 over, The square root of 6 plus the square root of 6 is 2 square root of 6, and that's how I can leave my answer. Okay, so after this, go ahead and go on to MathSpace and give homework number 2 a try. Homework number 2 is due on Sunday. So go ahead and give that a try. It is just like this. You'll want to have paper and pen with you probably.